Hey Algebra 2 students, welcome to week 6. I am out of town today, so there is no live week 6 meeting. You'll just be watching this recording. In week 6, we're going to pick up right where we left off at the end of last week. In week 5, you learned how to multiply rational expressions. Today, we're going to divide rational expressions. Now remember, rational expressions are fractions. So let's start by reviewing how you divided fractions. When we divide fractions, what we do is we multiply by the reciprocal. The reciprocal means that we flipped the top and bottom of that fraction. You might have learned this before with the phrase keep, change, flip. Let's see what that means. We have 2/3 divided by 8/5. To divide that, we're going to keep the 2/3. We're going to change the division to a multiplication, and we're going to flip the second fraction. So instead of 8 over 5, we flip, so we can write that as 5 over 8. So 2/3 is the same, 2/3 divided by 8/5 is the same as 2/3 times 5 over 8. So when we multiply, remember we multiply straight across the top. 2 times 5 is 10. 3 times 8 is 24. We can reduce that as those are both divisible by 2. So that is the same as 5 over 12. Let's see what this looks like with a rational expression. We're going to take x squared minus 2x minus 15 over 2x and divide that by x minus 5 over x squared. Let's start by rewriting this as a multiplication problem. Remember, keep, change, flip. This problem can be rewritten as x squared minus 2x minus 15 over 2x times x squared over x minus 5. Now it's a multiplication problem, which is what you did last week. We're going to start by factoring the top, x squared minus 2x minus 15. We are looking for two numbers that multiply to equal 15, but add to equal -2. In factored form, that's x minus 5 times x plus 3. There's nothing I can do with the 2x or x squared over x minus 5. Now, if you're having a hard time factoring these, often these were set up that they will simplify down. So sometimes looking at the other fraction gives you a good spot of what you might have as a factor. Here, notice I have an x minus 5 as my factor. This means before we multiply, we're going to reduce. We can simplify anything on the top that's divisible by anything on the bottom. So I notice I have an x minus 5 and an x minus 5. Those cancel out. Also, I have an x squared and an x. So dividing both by x means I'm going to get rid of the squared. So I just have the x on the top. Okay, there's nothing else that I can cancel. So now I'm going to go ahead and I'm going to multiply. So multiplying across the top, I have x plus 3 times x. And on the bottom, I have 2. And it's okay to leave your answers in that factored form. Let's try another one. This division problem, x squared minus y squared over 2x squared minus 2 divided by x minus y squared over xy minus y. First step is to write this as a multiplication problem. Keep, change, flip. So here's my problem rewritten as multiplication. Notice I'm multiplying by the reciprocal, so I flipped that second fraction. Now I need to go ahead and see what I can factor. X squared minus y squared. That's the difference of perfect squares. I can factor that as x minus y times x plus y. On the bottom, 2x squared minus 2. I see I have a common factor. I can divide everything by 2. So if I factor out a 2, that gives me x squared minus 1. In the second fraction, I can factor out a y. So factoring out a y gets me x minus 1. And then on the bottom, x minus y squared. If you want, you can rewrite that as x minus y times x minus y, as it might help you see what you can cancel out. Okay, so looking at this, first thing I notice is that I have an x minus y here in the numerator and over here in the denominator. Okay, as I look at my others, remember, these are full factors and I need to keep them together. So I can't just cross out an individual variable when it's part of an addition binomial. So as I look at this, oh, I notice, actually down here, I could have factored this further. I'm going to rewrite this, x squared minus 1. I can actually factor that. Again, that is a difference of 2 squares. So this I could write as still 2, x minus 1 times x plus 1. Okay. When I do that, that was nice because then I have an x minus 1 here and an x minus 1 there. Okay, I think I'm done simplifying. So now I'm going to go ahead and multiply. So again, go straight across the top. And I'm going to write my answer up here towards the top because I ran out of room. So on the top, we have x plus y times y divided by, on the bottom, I have 2 x plus 1 times x minus y. And that is our solution to our division problem. Before we get to our next new skill with rational expressions, we're going to do a short review on proportions, as we'll be using this to solve rational expressions. So remember, proportions are equal fractions. So for example, 2 over 3 equals 5 over x. And we can solve proportions by cross multiplying. That means that we multiply diagonally. So 2 times x, and that's going to equal 3 times 5. So 2x is equal to 15. We would solve for x by dividing by 2, meaning x would be 7.5. Let's see how we're going to apply this to rational expressions. So on your worksheet, there's going to be 2 different types of rational expressions. The first type are going to be written for you as proportions or equal fractions. So again, we're going to cross multiply, solve our equation. But remember, we always have to double check to see if we get a value that would give us a 0 in the denominator. So let's go ahead and cross multiply. We will take 5 times 2x plus 3 and x plus 1 times 2. So we multiplied on the diagonals and set them equal to each other. Now we're going to simplify. We have to make sure we distribute. So 5 times 2x is 10x. 5 times 3 is plus 15 equals, again, distribute over here, 2x plus 2. Okay, so in order to solve, we're going to gather our x's on the left-hand side. So I'm going to subtract 2x from both sides. So 8x plus 15 equals 2. Subtract 15 from both sides. So 8x would equal negative 13. Divide both sides by 8. So x is going to equal 1.625. Now we have to double check that answer. I accidentally covered up our original problem. So what I want to check is what happens when I put 1.625 into the original problem. I need to make sure that I don't get 0. You could plug it in and evaluate, but right now I can tell if I add a positive number to 1, it's not going to be 0. Same thing if I do 2 times 1.625 plus 3. So in other words, x equals 1.625 is a good solution. Our next problem, x over 2 equals 25 over x minus 5. Those are a proportion. It's 2 equal fractions. So we're going to be able to just cross multiply. So x times x minus 5 will equal 2 times 25. On the left, we distribute. So x squared minus 5x equals 50. Our goal is to solve for x. I notice that I have an x squared and an x term. That means we're going to need to factor this. So let's move everything to the left side. So x squared minus 5x minus 50 equals 0. To factor this, I'm looking for two numbers that multiply to equal negative 50, but add to equal negative 5. I can factor this as x minus 10 times x plus 5 equals 0. Okay, so that gives us two solutions. X minus 10 equals 0, and x plus 5 equals 0. Solving those both. So over here, if we add 10 to both sides, x is going to equal 10. On the other solution, we're going to subtract 5 from both sides. So x is equal to negative 5. Then I need to go back and double check to see if this solution works. Remember, what we don't want is we can't have this denominator. Whoops, wrong color. Our denominator cannot equal 0. So if we take 10 and we put it in for x in that red highlighted area, 10 minus 5, that's 5. It's not equal to 0. What if x equals negative 5? Negative 5 minus 5 equals negative 10. So again, that one does work as well. If I got an answer that equaled 0, I'd have to cross out that solution. Now, what if your rational expression is not a proportion? Often, you could do some algebra to make it into a proportion. So in order to do this, there are a couple different things you're going to look for. What you want is you want to gather and combine things that are just constants. So you might have to move it to the other side of the equal sign. You can use your calculator if they don't have a common denominator. Another thing that we can do is we can look and gather and combine fractions that do have like denominators. So they might be rational expressions, or we might need to make a common denominator. A third thing we could think about doing is moving all the things that do not have fractions onto one side of the equal sign and trying to isolate so that only one side has a fraction. Then, once you have that, it's just like the last problems, where you're going to solve by cross multiplying. Our first problem is 3 plus 2 over x equals 5. Okay, here I don't have proportions. I don't have equal fractions. I have 3 plus a rational expression equals 5. So what I want to do is I want to combine and move the 3 to the other side. We're going to subtract 3 from both sides. So then 2 over x equals 5 minus 3 is 2. So 2 over x equals 2. You might look at this and say, well, that still isn't two equal fractions. Here's the key thing. I can divide anything by 1, and it doesn't change the value. So if I have something that's not a fraction, just put it over 1, and that will help you see how we can cross multiply. So we'll take 2 times 1 will be equal to x times 2. So in other words, 2 is going to equal 2x. I want to get x by itself, so I just have to divide everything by 2. 2 divided by 2 means that x is equal to 1. Again, we can double check. X in the denominator, if I put 1 in there, that is a valid solution. Our next problem, 2 over x plus 2 over x plus 1 equals 6 over x plus 1. I need to have just one fraction on each side. So I'm looking to see what I can combine or simplify. I notice that I have two fractions that have a common denominator. That means if I combine them, I'll reduce it down to one less fraction. So I'm going to subtract 2 over x plus 1 from both sides. So on the right side, I now have fractions with a common denominator. 6 over x plus 1 minus 2 over x plus 1. So remember, we're going to subtract the tops. So 6 minus 2 is 4. Bottom stays the same. So this simplifies down to 2 over x equals 6 minus 2 is 4 over x plus 1. Looks like I now have proportions, so we're set to cross multiply. 2 times x plus 1 will equal 4x. Multiply that through. 2x plus 2 equals 4x. Solving for x, we're going to subtract by 2x. So then I have 2 equals 2x. Divide both sides by 2. And x is equal to 1. Let's do one last example. 4 over x plus x equals negative 5. What I really want to do is get that 4 over x by itself. So if I subtract x from both sides, let's see what we have. So minus x. So 4 over x will equal negative 5 minus x. Just like in an earlier problem, we can make that into a fraction by putting it over 1. Now we'll cross multiply. So 4 times 1 is going to equal x times 5 minus x. So this gives us 4 times 1 is 4 equals, we're going to multiply the x, distribute it through. X times negative 5 is negative 5x. X times negative x is negative x squared. So we're going to have to factor. I want to get all my terms on one side. Since I have a negative x squared, I'm actually going to go ahead and move that to the other side. So I'm going to add x squared, and I'm going to add 5x. This way I get rid of my negatives. So this is actually equal to x squared plus 5x plus 4 equals 0. So we can factor this. What we need are two numbers that multiply to equal 4, but add to give us 5. So that would be x plus 1 times x plus 4. X plus 1 equals 0. That means that x would be negative 1. X plus 4 equals 0 means that x is negative 4. Double check and make sure those values work in our denominator. So far in weeks 5 and 6, you've learned some pretty complex skills. So there is an additional assignment in week 6 designed to just have you practice all the stuff you've learned. It does have some guided notes to hopefully help you lead through the steps so you can really master everything that you've learned. If you have questions, again, please remember to reach out or stop into the Academic Success Center. I hope you have an awesome week.